Good evening, everybody. I hope you all are well. Thanks for joining in on the session. Maybe just gonna wait maybe 2 more minutes and then I'll start. Okay, cool. I think I'm gonna start. So, welcome again, everybody. So, in our first crash course session, I would like to speak about stroke. Okay, now there's a lot of content, so I'll just try my best to cover kind of the high-level themes um, in this case. Okay, so the first thing basically to approach stroke is basically firstly importantly to understand the anatomy of the blood supply to the brain. So before I go into the classification and cause of stroke, I'm just going to do a brief overview on the blood supply to the brain. Okay, so blood supply to the brain. Okay, so first of all, it's important to understand that all blood supply come from the heart. Okay, now we know that the aorta, so just say for example, that's the aorta, okay? The ascending aorta and then the descending aorta, there are three branches. There are three branches of the aorta, okay? So you get the brachiocephalic trunk. So the first one over here is so let's say that's the aorta, okay? That's the aorta. And let's say this branch over here is the brachiocephalic trunk, okay? And let's say the second branch is the left common carotid artery, okay? So it's the left common carotid artery, smaller. And then the third branch over there is the left subclavian artery, okay? Okay. Now by the brachiocephalic trunk, okay, there's two branches that branch from there. Okay. It's the right subclavian artery and the right common carotid artery. Okay, so over there from the brachiocephalic trunk, you have your right um, subclavian artery. Sorry for the spelling. Okay, okay, as well as your right common carotid artery. Okay, right common carotid artery. Now, from the right common, oh shit, happened the, okay. So just make it a bit smaller. Okay. So from the right common carotid artery, you basically have the branching, just see over here. Yeah. So the right common carotid artery then branches into your right internal carotid artery. Okay. So the right common carotid artery, you have a branch going into, can you just let someone over there? Okay. You have a branch going into your right internal carotid artery. Okay, right internal carotid artery. And then if we just look at the right internal carotid artery. Now from the right internal carotid artery, it branches into the two very important arteries, which forms part of your circle of Willis, and that is your anterior cerebral artery, anterior cerebral artery, as well as your middle cerebral artery. Okay, so that's your middle cerebral artery. Okay, and then if you just go backwards quickly by the right subclavian artery, now the right subclavian artery gives rise to your, just take my pencil over there. Okay, the right vertebral artery come from there. Okay, so your right vertebral artery come from the right subclavian artery, which goes into your basilar artery. Okay, and that's important. That artery is also quite essential, forms part of your circle of Willis. Okay, the basilar artery. Okay. So we can see over here from the aorta that it has three branches, right? Your brachiocephalic trunk, left common carotid artery, and your left subclavian artery. The brachiocephalic trunk branches into your right subclavian artery and your right common carotid artery. The right common carotid artery, one of the important branches is your right internal carotid artery, which gives rise to your middle cerebral artery and your anterior cerebral artery. Your right subclavian artery gives rise to your right vertebral artery, which gives rise to your basilar artery. Okay, and this brings me hi, specifically, your hand is up.
Sorry, I'm not sure if it's just on my side alone, but the rest of the drawing from the right vertebral artery is hidden. So I don't know if you can try moving it down, or I'm
Oh,
not sure
okay.
if it's my
Let's
side.
check quickly. Can you see now?
I I can see, but only till that level. I don't. You
Oh,
can
must I
zoom out
zoom out
the.
the board now?
Okay, let me try zooming it out from my side. I still.
Can the other see though?
Yes, I think you need to move your cursor to the right and then zoom out.
On my side?
No, Sipe
Oh,
can.
okay, okay. Thank you. I have.
Okay, cool. Okay, so that brings us now to the circle of Willis. Okay, so just quick recap on the circle of Willis quickly. So, okay, let me just do it over here. So obviously, you know that. So you have your anterior cerebral artery coming in over here. Okay, you have your anterior cerebral artery coming in. Then you have your right that. Then you have your middle cerebral artery. So over here, that's your internal carotid artery over there, which gave rise to that middle cerebral artery. I'm just doing just single lines, okay? This is just like a mechanism like for you to remember it for the exam. Okay, so over here, that's your anterior cerebral artery, that's your middle cerebral artery, and then you have your posterior cerebral artery over there. Okay, so that's your posterior cerebral artery. And then between it, you get your communicating arteries. Okay, so over here, that's then your anterior communicating artery. Uh, this is also two anterior communicating arteries over there. Okay, and then you have your posterior communicating artery over there. Okay, so let me just do the things quickly. Okay, so that is okay. I'm gonna use abbreviations now. Okay, anterior cerebral. So that's your anterior cerebral artery. That over there is also your anterior cerebral artery. Over here, that is your middle cerebral artery. Over there, that's also your middle cerebral artery. And then this one over here is your posterior cerebral artery. They can possibly ask you to draw this in the SAQ as well. So it's just like an easy way to remember how to draw it. Posterior cerebral artery. Okay, so you have anterior, middle, and posterior cerebral artery. And then between them, you have communicating arteries. Okay, so between your anteriors, you have your anterior communicating arteries. I'll just use CC for communicating. Okay, and then over here, that is also an anterior communicating artery. And that artery over there is the posterior communicating artery. Okay, now going further. Okay, so then these two over here. Okay, so that's over there, and then obviously you get your, it's almost like a long neck or a trunk. So that's your basilar artery with pontine arteries. Okay. Cerebral. Yeah, got that. And then there's also like a small branch over there that's called superior cerebellar. That's your superior cerebellar artery. Superior cerebellar artery. Okay. So that over there is your superior cerebellar artery. This over here, this long trunk over there, that's your basilar artery. Okay. And the small whiskers is the pontine arteries. Okay, cool. So basically, the circle of Willis is formed by five things. Okay, it's your, oh yes, I forgot to mention the internal carotid artery over here. So over there, that over there is your internal carotid artery. Okay, that over there. Okay, and we can obviously see that that internal carotid artery, obviously, it gives rise to your middle cerebral artery as well as your internal cerebral artery. Okay. So basically, your circle of Willis is made up of your internal carotid artery, your anterior carotid artery, your communicating artery, so the anterior and posterior communicating artery, as well as the posterior cerebral artery. Okay, and then we can maybe go a little bit further down as well in our circle. So obviously over here you have your, so we can go maybe further down. So this over here, that's your superior cerebellar arteries. Now we're going to the cerebellar arteries. This one over there is your um, anterior inferior cerebellar artery. Okay, so that over there is the anterior inferior cerebellar artery. And then this two branches over here was that vertebral artery. Okay, so you could see there, no? So that was your vertebral artery. So basically, that branch over there, that is your vertebral artery. Vertebral artery. Okay. Sorry, and then branching from the vertebral artery, so you have an anterior inferior cerebellar artery, and then you also have your posterior inferior cerebellar artery, branching from the vertebral artery. Okay, so that is your posterior inferior cerebellar artery. Okay, artery. And then last one, last artery I'm going to mention is the anterior spinal artery, which branches in the middle from the vertebral artery. Okay, going down. Okay, so that is your anterior spinal artery. Anterior. Okay, so that's the basis for the blood supply to the brain. Now, let's speak about quickly regarding the homunculus. Okay, now the homunculus is very important because um depending on the watershed zones and basically like which, so they would like some questions could ask like which like watershed zone is affected, or they might give you like certain uh symptoms that the patient might have, right? And to understand the human homunculus and the blood supply basically to each area is really, really essential to like answer the questions. Okay. So let me just, yeah, there we go. Okay. So just branch over there. The human homunculus. Homunculus. Okay. So for the human homunculus, so I'm gonna just do it. Okay. So I'm kind of gonna draw like a quarter circle over here. Okay. So it's almost like a cross section through the brain, and then I'm also gonna draw a part over here. Okay. Now obviously we know that there are two parts. Okay. You have a motor output, right, to the motor cortex, and you have your sensory somatosensory cortex. Okay, now for this part so that's going to be our motor cortex, and on the left part it's going to be our somatosensory cortex. Okay, somatosensory cortex. Okay, so first of all, there are three watershed zones, right, that we need to understand. And how do we know the divisions of it? Okay. Now, there's a demarcation over there, and there's a kind of a demarcation over there. So that demarcation is called your, just go to quickly. Yeah. So it's the anterior horn of your lateral ventricle. So the one in front, or the one on top, is called the anterior horn of your lateral ventricle. So that's the anterior horn of the lateral ventricle. And this demarcation over here is your posterior horn of the lateral ventricle. Okay? Posterior horn of lateral ventricle. Okay? Now the reason why like these demarcations are quite important because this kind of, just try to imagine, right? So basically, let me just see. Okay, cool. So this part over here is known as your ACA territory. Okay, just okay. So this part over here is known as your ACA territory. The middle part is known as your MCA territory. MCA, right? And the bottom part is known as your PCA territory. So it's like your anterior, middle, posterior, okay, cerebral arteries. And the bottom part is the bottom half, or bottom third is your PCA territory. Now, depending on which territory the infarction is or where the stroke actually happens, it will affect certain parts of the body. Okay, I'm just gonna, okay, wait, I'm rather gonna maybe read through. So that's just to indicate the territories. So you get your ACA territory, your inside territory, and PCA territory. And between those territories, you have the cortical border zones. Okay. So just use different color quickly. Yeah. So you have a cortical border zone between your ACA and your NCA, which lies over there. You have an internal border zone, which is kind of internal. It's kind of just next to that, the ventricle in the middle. And then you also have your another cortical border zone between your NCA and your PCA, okay? And that demarcation over there. So if you have a look at the image, right, on the brain of the I forgot now whether it's the cross section or the sagittal section, but if you look, you must try to figure out where's your demarcation. So that anterior wall horn of the lateral ventricle demarcates it very nicely between the anterior and the middle territory, and then that posterior horn of the lateral ventricle kind of marks it very nicely between the middle and the posterior cerebral artery territory. Okay, so now um going more into the homunculus. Okay, so just use black. Okay. So, oh, should we just make it move around, go back. Okay. So, okay, there we go. So how we can remember it? So if you want to remember it, right, broadly. So if you want a broad kind of understanding of it, remember that there's three main umbrella regions. Okay. You have a medial region. So medial is more like here in the middle. So you have a kind of a medial region. You have a superior and lateral region, okay, which lies around about here. Superior and lateral region of that brain, okay, of that of the brain, lateral region. And then you also have a inferior region. Okay, so this would be our inferior region, right? So the medial region controls the lower extremities, meaning like your legs and your feet. Okay. So your feet is basically that part controls the feet lies around about there, and your legs lie around about there. Okay. So just try to remember medial is the lower extremities, feet and legs. Okay. Superior. So, for example, if a patient has a paralysis in the feet, right, or the legs, which part of the territory is affected? That's the ACA territory. Or they can ask you which artery is affected. Then you're going to know, oh, it's the anterior cerebral artery because the anterior cerebral artery supplies that medial region. Okay. Then moving on to the superior and the lateral region. Now, the superior and the lateral region controls the trunk and the upper extremities. So, broadly speaking, so we have trunk, arms, and hands. Okay. Trunk, arms, and hands. So, we just include it over there. Okay. So, we have our trunk, the arms, and hands. Okay. So, trunk, arms, and hands. Okay, okay, and then over there. Okay, Cool. And then for your inferior region, basic things to remember for your inferior region is your face, your tongue, and the throat. Okay. So anything in the anything in the face that's affected, right? Face, tongue, and throat. The throat can also be, we can also call it the pharynx essentially. Okay. Tongue and the throat. Okay. See. Face lies around about there. So the face kind of still borders around the MCA territory. The tongue also kind of borders around the MCA territory. When it comes to your throat, right, you will see that the throat, then you might be thinking of, oh, because it's very much inferior, we're thinking of PCA, an infarction in the PCA territory, right? Posterior cerebral artery, okay? So that is our motor cortex. The somatosensory cortex is kind of really basically exactly the same, right? Where you have your medial region receiving input from the lower extremities, right? You have your superior and lateral regions, which receive input from the trunk and your upper extremities, which is your hands and your arms. And then you have your inferior region, which receives input from the face and tongue, right? Basically, your oral structures. Okay. So that's just a brief overview regarding the homunculus. Okay. Let me just see over here. Running out of time. Okay, so I think we have 10 minutes left. So if we do run out of time, there's like usually a 7-minute gap in between. Then I'll just resend the link in 7 minutes time. Okay. So we have the demarcation line in this regard for the ACA and the MCA territory. So right up until the arms and the hands. Okay. Okay, so that's your ACA, MCA, and PCA territories. Okay. Okay, so now I actually want to explain the causes, the broad umbrella terms for stroke. Okay, so what are the causes of stroke? Okay, so how do we classify stroke? So before I go, we need to now classify stroke, and I specifically want to focus on the Oxford classification of stroke. Okay, but before the Oxford classification, just going to let me just see. Okay, so first of all, there are obviously you have your stroke and you have your TIA. Okay, so obviously if it's more than 24, the more than 24 hours, if the defect or your hemianopia or the paralysis lasts for more than 24 hours, then we know, okay, this is a CVA essentially. Okay. And obviously if it resolves within 24 hours, okay, so yes, right, so if it's basically within 24 hours, then we know, okay, this is definitely a transient ischemic attack. If it's more than 24 hours, then we know, okay, this is definitely a CVA, right, a cerebral vascular accident or stroke essentially. Okay. Now, the two main umbrella bodies are ischemic strokes and hemorrhagic strokes. Okay, so let me just see over here. Ischemic, ischemic strokes. So obviously with ischemia, there's a blockage somehow, okay? Essentially there's a blockage, and then with hemorrhagic strokes. It's basically just hemorrhagic, so bleeding, increase in bleeding, okay? So for the ischemic strokes, there are two types of ischemic strokes. You get um, your thrombotic stroke, okay? Your thrombotic as well as the embolic stroke, okay? Thrombotic and embolic. And then with the hemorrhagic stroke, there's the intracerebral hemorrhage and the subarachnoid hemorrhage. Okay. So intracerebral as well as the subarachnoid. Okay. Now moving on to the Oxford classification. Okay. Now the Oxford classification basically uh, divides into four parts. Okay. But there's just one more thing I have to mention with regard to the blood supply to the basal nuclei. Okay. So I forgot to mention the blood supply to the basal nuclei. So if you have a look at the brain, so that's the blood supply to the brain. We shouldn't forget the blood supply to the basal nuclei. So your internal carotid artery. So this is basically another cross section of the brain. Okay. So okay, sure. Let me just draw a better picture. So it's just a very rough sketch of cross section of the brain. So just picture that that is your lateral ventricles, okay? Um, and then just picture that this is part of your basal nuclei, okay? Now what supplies your basal nuclei, okay? There and there, okay? So, um, yeah, so your internal carotid artery comes in over here, right? And then it branches into your middle cerebral artery, branches into your middle cerebral artery. So that's your internal carotid artery, branches into your middle cerebral artery. And then from the middle cerebral artery, there are arteries called the lenticulostriae arteries, right? Lenticulostriae arteries. And those lenticulostriate arteries supplies essentially your basal nuclei. Okay. Um, yeah. Those are the lenticulostriate arteries. Okay. Okay. So now we're gonna go quickly to the Oxford classification of stroke. Okay. Understanding your anatomy actually helps a lot with understanding the Oxford classification. So essentially, there are basically four parts to your um, Oxford classification. Okay, just trying to get myself again. Okay, there we go. Okay, so you have a total anterior circulation, posterior anterior circulation. So how we can maybe divide it into is that we can say, okay, you have anterior, you can have an anterior infarct, or you can have a posterior infarct, okay, or you can have a lacuna, right? A lacuna infarct, okay. Now, the anterior infarct, remember there are two parts to anterior, okay? You can have a total anterior or a partial anterior, Okay, so can have a total anterior infarct or a partial um, anterior stroke. Okay, anterior circulation stroke. So what component does the anterior circulation stroke affect? So it affects the anterior and middle cerebral artery territories. Okay, so the total affects the anterior and middle. Okay, you know, I'll give the abbreviations. So ACA as well as MCA territories. Your partial also ACA and MCA territories, but remember for partial, it's either or. So it's not both. So it's either your ACA or your MCA territories. Okay. Okay, there we go. So how will the territories basically be affected, right? What will happen? How the patient basically respond? So there are three features that should be present for a tax. Okay, some people call it tax, some people call it tacky. It doesn't actually matter, but we can call it tacky. So the abbreviations are tacky. This is Pachy. Posterior is Pocky. So the I stands for infarction. And then lacuna for lackey. Okay, lacuna infarct. So for total, you have a hemiparesis or a hemiplegia. Okay,